last talk, and then we go for drinks, right? But this is the fun one. I've been waiting for this all day. Chris Posta is going to talk to us about the future of Istio, which is sidecarless. Christian, as he's walking up to the stage, is a global field CTO at solo.io, and he supports customers and end users in their adoption of cloud-native technologies. Christian Posta is a published author on Manning and O'Reilly publications, open source contributor, blogger, and quite a sought-after speaker on Envoy, Proxy, Kubernetes, and all those technologies. After this talk, Chris has got a book signing event outside, so follow myself and Chris along as we go to that event. For now, I will let Chris talk about the future of Istio, which is sidecarless.
Thank you.
Welcome back.
Thank you. The HDMI plug is where? Oh, right here. Yeah, give me a second.
Just noticed you got a Mac.
Yeah.
So I'm going to give you this little box so we don't get any issues.
Oh. What do you want me to do? I'll let you do it. Wi-Fi. All right. 1 second while we set this up. No. All right. Set my timer. All right. I think we're ready now. I don't have a lapel, right? I have to stand right here? All right. Awesome. Well, thank you all for coming out in person, for joining me on this talk. I know it's the last talk of the day. Did I hear right that beer is after this talk? Yeah, good for the beer, yeah. I agree. All right, so I'm going to be talking about some technology-specific stuff. I know here at API Days, things are a little bit higher level, but this is a specific technology that's very relevant to APIs, especially how you manage policy for interactions between APIs internally. So just out of curiosity, through show of hands, if you could, how many people know what Istio is? Okay, awesome, good. I've been talking about Istio, honestly, for the last 5.5 years, and slowly it's been going up, the number of hands. So no? All right, well, I guess we'll do it. Still no. What is going on? Does that work? All right. So we are doing a book signing afterward, right outside at the Solo booth. Like in the introduction, let's get this weird thing here. I've been involved with distributed systems and some of the open source projects behind solving some of the problems of how services communicate with each other. Most recently, in the last 5.5 years, I guess, Istio. And I joined Solo.io, which is a software company that works with organizations adopting this type of technology. And we built, why is it not fucking working? All right, well, we build mesh technology that, when we see people trying to adopt service mesh, API gateways, these types of technologies, how do these pieces come together? The types of additional tooling that they build on top of it, workflows, they think about tenancy, how do they expose this to their developers and make it consumable? So a lot of that stuff people have kind of done on their own and is non-differentiating heavy lifting that we've wrapped up into a product based on Istio. It's a drop-in replacement for community Istio, and allows you to be up and running much faster with service mesh technology. And Solo, we've been growing quite a bit. We're worldwide. We have a good sized presence here in Australia now, and generally in the APAC region. So definitely want to encourage to reach out to us if you're interested in this technology. We are hosting a happy hour as well afterward, just outside the venue. So if there are any questions that I'm not going to be able to cover in this 17 minutes that I have left, please stop by, grab a drink, and I'll tell you what I really think about things, especially in answering any questions here tonight. So Istio is something that I've been involved with for quite a while now, and I've seen the adoption of this technology expand over the last, certainly after the last few years. And we at Solo have been working with some of the largest deployments of service mesh, and recently we, on the behalf of the community, announced that we're going to donate Istio to the CNCF. Now, Solo, since we have this point of view of working with these organizations adopting this technology, we see some of the struggles, some of the complexities, especially when you bring it into an enterprise, a bank, a big retailer, insurance. These are not, the open source project itself, doesn't envision and understand all of the intricacies and compliance and regulatory and so on that happens in these large organizations. So we see some of the struggles, and what we wanted to do is improve some of the experience, especially around operating something as complex as a service mesh. So last week, Solo and Google, actually we partnered with Google. We've been working on this for quite a while. We announced Istio ambient mesh to the community. So this is, everything that I talk about today is open source. And what that is a sidecarless approach or data plane for Istio. And I'll go into the details of why that might be important and the benefits that you would get out of an approach like that. But just coming back to what Istio is today, or what most service meshes, how they're built today, you take a little proxy that handles the traffic on behalf of the applications. You inject it or deploy it right next to the application, and this proxy is supposed to handle cross-cutting networking, application networking type concerns, things like telemetry collection, what's happening on the network, number of requests that are going through, failing requests, and so on. Things like traffic routing, traffic splitting, authentication, authorization for traffic coming into an application, rate limiting, and things like MTLS and so on. So the traditional approach to service mesh has been inject this little proxy next to every application instance, and then we can program the proxies to behave a certain way depending on the policies that we want to allow on the communication between the services. Now, we published back in December a blog post that goes into some of the work that we were looking at in terms of speeding up the service mesh, reducing some of the latencies, introducing a technology called eBPF that allows you to control the network at a lower layer in the kernel so that we can bypass some of the networking stack when it makes sense. And we documented how that would fit in with a modern service mesh today. And we went through a few different patterns, starting with the sidecar. What are some of the things we can do to optimize a sidecar? What happens if you move the proxy outside of the workload, and some of the trade-offs that you have to make there? Things like resource consumptions. You get better resource consumption if you collapse everything down into a single proxy. But you trade off really important properties like tenancy and a security blast radius and noisy neighbor type concerns. Right? So if you look at one extreme on the sidecar or one extreme on the shared proxy model, there's various trade-offs that you have to make. But those are not the only two options. There's an approach in the middle that, and you can tweak and tune and try to balance out the best of both worlds that we ended up implementing in Istio Ambient that I'll talk about. Like I said, we announced it last week. There's a partnership between us, Solo.io, and Google. And we brought it to the community initially as an experimental approach to this sidecarless data plane. But at Solo, we are working with customers to harden this and mature this as quickly as we can. And the number one focus on it is how do we improve the operability and operations of the service mesh? How do we onboard applications easier? If you don't have to inject sidecars, the applications don't even know that it's there. How do you do upgrades? So with the sidecar model, you would have to inject a new data plane, restart the application, and try to coordinate that across all of the applications that you restart so you don't get rolling failures and outages. Right, it's a little tricky and a little bit complex. When there's no sidecar deployed there, then the app doesn't even know that the data plane might be getting an upgrade or a CVE patch. And you can do this very frequently without having to coordinate with the applications as much. And so so operations was a big concern. We also get the benefit of some of the cost savings of not having to run so many sidecar or proxies at all. We get some savings in terms of performance because we can optimize the paths between the services now if we don't need certain capabilities, and I'll talk about that in a second. So basically what we did with the service mesh, if you compare it to what you saw in the previous slide where each workload had its own proxy, what we did this time is we split up the data plane into two different layers that can work in conjunction with each other, or you can opt in only as needed. So what I mean by that is we call one layer the secure transport layer. This layer is only responsible for MTLS and layer 4 telemetry, very simple. And this also happens to be probably the most dominant use case that people come to Service Mesh for, is I want mutual TLS. And what they end up seeing is, all right, well, you want mutual TLS, all right, inject these sidecars everywhere, and then they realize, oh man, I deployed my pod, the workload container came up first, the sidecar container came up slower, and when the workload tried to communicate out over the network, the sidecar wasn't ready, so the whole thing failed. Right? Or you deployed a Kubernetes job, and a Kubernetes job will run to completion. But if it has a sidecar, the sidecar continues to run. So now you have these long-lived jobs that are actually done, but now you have to somehow manage, So you get all of these nuanced scenarios that you run into because the sidecar is not as transparent as we want in the application. And you're adopting all this extra stuff and complexity when all you want is mutual TLS. So in Istio Ambient, we've split the layers so that if you just want mutual TLS, then you can opt into that by enabling it. In Istio Ambient, I'll show you a demo. You just label a namespace, and the workloads now become part of the service mesh. And you bypass any layer 7 handling, things like retries, traffic splitting, understanding HTTP requests, and that kind of stuff, because you don't need that if you just want to start off with mutual TLS. So now you get a performance gain. Everything stays at layer 4. You get the properties of zero trust, so you get strong identity, you get mutual TLS certificates. Things move to this secure transport layer. If you need layer 7 capabilities, you can add that in. So here's kind of what it looks like when you're staying within the secure transport layer, zero trust, or you're going through these, basically a CNI plugin that acts as an agent for the lower layer networking, but adds mutual TLS certificates to these calls. If you do need layer 7 capabilities, which most service meshes, that's a big reason why people adopt that, then you can opt into that by deploying what's called the Waypoint Proxies. The Waypoint Proxies kind of take over the role of the sidecar, but they're not deployed as a sidecar. They're deployed almost like a gateway per workload type, or per identity. And so this is really important because we don't share the layer 7 proxies across a bunch of different identities, which could potentially be a security issue, noisy neighbor issue. So we split them up, And I keep calling it that, the secure transport layer knows when to route to the layer 7 proxies when layer 7 policy needs to be applied. Right? Now, there's a lot of benefits to this. You don't get those same race conditions between the containers. You can do upgrades much simpler. It's much more simple and transparent to the applications. So CVEs that come out can get patched immediately without disrupting the applications. You maintain the properties of isolation and eliminating noisy neighbor problems, kind of like you have in the sidecar today. And you're able to incrementally adopt some of the features of the service mesh, like starting with mutual TLS without any of the other stuff, and without taking some of the risk that comes along sometimes with some of these layer 7 components. Let me just jump to a quick demo and maybe make this a little bit more clear. Again, if you have questions, I know I'm going kind of fast here, and this may elicit a lot of new questions. If you go to istio.io, we've written 3 blogs on this: the introduction one, the getting started one, and then I wrote one on security that goes into a lot of details about the security properties of Istio Ambient. But like I said, come join us for drinks. I'm happy to answer more questions. Let's see if I can do a quick demo here. Will that show up right there? All right. Let me see. Can you all see that okay on the screen? Or do you want me to? I can make the text a little bit bigger. Hopefully my Wi-Fi holds up. All right, so what we're going to do is we're going to take a look at a Kubernetes cluster here that has some workloads deployed. Very simple, sleep application and hello world. Sleep calls hello world. You can see over here on the right-hand side, these applications have been up for quite a long time. If I go into the sleep application and try to call hello world, I should be able to make the call, hopefully. Oh, I misspelled hello world. Hello world, let's try that. All right, and the call goes through, but this is not really anything special. This is just Kubernetes. I'm making some calls to some services. Now let's go ahead and let's add the service mesh in, but without using sidecars and without restarting any applications or doing sidecar injection or anything like that. So to do that, what we're going to do is we're going to come over here. We're going to install, install Istio using Istioctl. If you're familiar with Istio, it's a familiar CLI tool. And what we're going to do is we're going to set the profile of our installation to ambient. This will enable us to use the ambient data plane. So if we come in here and we'll give that a second, this is going to create the Istio system namespace, install the Istio D control plane component. It'll install some of the components needed for the secure transport, and then we'll also install some of the CNI plugins that make all this stuff work. So now if I come back here and I take a look, let's go ahead and look at a different view of the Kubernetes cluster here. If we take a look at our namespaces, we should see an Istio system here. Click into that. Down here on the bottom, we can see some of those components. The CNI plugin, Istio D is here, and the zero trust tunneling that we've set up. Okay, so let's add the workloads sleep and hello world into the service mesh, and let's just take advantage of the mutual TLS properties to begin with. So to do that, what we're going to do is we're going to label our default namespace, as you can see here, with this particular label. Now, when I add this label, Istio Ambient is going to go look in that namespace and consider that part of the service mesh. So let's give it a try. And our sleep service is running on this particular node, ambient worker. So we're going to take a look on the bottom pane at the secure transport component that's also on ambient worker. I'm going to take a look at the logs. We'll go full screen there. Now, if we go back into our sleep application up top and call hello world, we should see traffic is automatically redirected into this component, and it's handling the layer 4 connections mutual TLS, presenting mutual TLS certificates, and encrypting the traffic between sleep and between hello world. Now, if I had more time, I'll actually open up Wireshark and show you that it's encrypted, but at least right now you can see that traffic is flowing through that CNI component on the node. Now, let's say we do want to inject layer 7 capabilities. We do want things like retries, like fault injection, like traffic control. And in Istio Ambient, the way we do that is by deploying a Waypoint proxy that I mentioned. And remember, I said this is per workload. This acts as a little gateway per workload, per identity. So let's apply that to our cluster. If we come back to our cluster view, exit out of this, we should see that we have sleep, hello world, and now this new hello world Waypoint proxy that represents the hello world service account or hello world workloads. And now we want to, specify a layer 7 policy, maybe a fault injection policy that says whenever you're calling hello world, pause or delay the request by 5 seconds. So you can see that. We'll match on hello. And for every request, we'll delay it by 5 seconds. So if we apply that, now we have a layer 7 policy in place. If we go into the sleep application again and go to the shell and we curl hello world, we should see a delay, which we see now is hanging, and it should be about 5 seconds. And then we see a response now. So now this is policy being applied at layer 7, where the requests are being handled. Now, if we decide that, you know what, service mesh is not for me, I'm going to uninstall all of this stuff, and I don't want to deal with it, well, what we'll see is that the behavior of the service mesh gets removed, the applications are still not disturbed, there's no sidecar there, and things continue to work. Let's see, go into sleep, and we see that things continue to work like there was no service mesh there at all. So like I said, there's a lot of benefits to this. Operations is the #1 thing. You also see performance and cost. And really, the goal is to make it so that more workloads can be included in the service mesh with minimal friction and assuming the level of complexity and risk that you're willing to take for the features that you want. So let me stop there. I know I've run out of time. Like I said, we'll be signing books out there in the hallway. We'll be available for drinks and more questions. But yeah, I think that's my time. Thank you.
Are there any questions for Chris?
Happy to take questions.
Happy to take questions, yep.
There's one back there.
So a lot of products now, as a service, Knative is the new thing. We're getting a lot of interest from products that you're purchasing, and operations just can have a Knative control. And the problem with Knative is we know that sometimes it comes with the requirements for Istio, just the way it goes, because they structure everything saying, deploy this like this and we'll take care of the rest, and maybe we'll remotely manage it for you and all those sort of things. How does that work with your product, with these sort of things? Are you working within that plane? Do I need to go and break the Knative sort of, packages that are provided through? How do you see that sort of working?
Well, so what I showed today was all open source Istio. So, Knative consumes open source Istio, and Knative has a pluggable approach for how it handles layer 7. Yeah. It can include gateways and other stuff. So maybe you will see that this Istio ambient data plane gets pulled into Knative at some point. I'm not sure. Okay. From a solo perspective, we are working closely with Google around things like Cloud Run and Knative, or with Red Hat on Knative. And so there are integrations that we'll be bringing at some point around that.
That's all.
Yeah.
Thank you.
Thanks for the question. Anything else? All right. Thank you all.
Thank you, Christian.